morning, Palemon. Okay. So if you get these right, just put a little check mark. If you could use a different color pen or pencil, that would be great. We're just going to get in that habit. Now, I think I misspoke yesterday, and I think what I said was there was going to be a take-home quiz that I was giving you today that was due tomorrow. Does anybody remember hearing me say that? Yeah. I completely misspoke. Tomorrow, that's due Monday.
Oh.
Okay? So please forgive me. All right. Now, I would hope that the first 10, easy peasy.
See.
If you have the graphs in front of you, easy peasy. However, on the take-home quiz, they will not be provided. You cannot use the parent function survival guide. You need to internalize these things. How many guys went 10 for 10? Okay, but this was with access to the packet? Okay. So I think ones that I would maybe like draw attention to is this absolute value of x over x, right? That's probably one that wasn't really in your parent function list. 1 over x squared plus 1, oh, that didn't make it on the list. 1 over x squared, right? That's the one that does this thing. These are the ones I'd put on your list there. And negative infinity, good answer. Better answer? Does not exist because of unbounded behavior. Okay, that is the best answer, but I would accept negative infinity. I won't accept positive infinity if we're going to negative infinity. All right, and then the multiple choice, hopefully this went well too, and most of these were calculator active. First one is D, second one is B, third one is C. Do it right? Good. All right, so we can, before you put that away, let me tell you what tonight's homework is. Section 3, this is in the same part, this is on assignment 3. I'd like you to do problems 3, 5, 6, and 7, 11 through 15. 3, 5, 6, 7, 11 through 15. I am going to pick this up tomorrow for a grade. I've been giving you guys a couple of days to kind of get back into like school mode. And let's be real, get me back into school mode and fighting shape. Okay, so I've been going to the teacher gym and doing my workouts there. So that's due Friday. The other thing that's due Friday is the summer assignment round 3. That was the one involving all the limits and the derivatives. Many of you have already finished that. And you guys just had more time so that it would look really, really good. Okay? Very good. All right, so we're going to continue with the calculus in a brief moment. Friends at North Central, you might want to fast forward the video about 5 minutes. I need you guys to fill out a survey for me. I won't say anything more about the survey. Okay. There are no wrong answers. Carmen, I don't want you to worry about your GPA here. Okay, it is just a survey. All will be well. Has anyone seen Aaron's one? No.
I don't think Aaron was in the first one.
Okay. You need to put your final answers. Let's see how good I am with this. I lay Andrew. And where'd my Andrew go? Andrew. Celeste. Aaron, not here. Everyone wants to beat Giselle. Okay. Lewis. Stephen. Carmen. Ramon, Myra.
I'll take it for Aaron if you want me.
Oh, no, that's okay. And David.
the round 3 is done completely. Okay. Second, if you're dissatisfied with that, make the changes over the weekend. Finish this. Show me how well you can do with this. Myra. David. Okay. So part of it, number 1. We need to make sure that this happens. So you're going to have to be tomorrow earlier, best case, so we can bring this right up. Okay? It's not that accurate, but we could do it. Second, if you would like to improve upon this grade, you haven't done it. You okay? All right. So while you guys are finishing up the survey, the summer assignment, I did not go through and grade every single problem, because good golly, nobody would want that. Instead, what I did is in all the sections that I said were important, I picked a handful of problems, provided you some feedback. I don't think anyone got every single problem right, but I also wasn't grading this for like, did you get the question wrong, in which case I'm going to deduct some points. It is like there are 5 or 6 people that got 100 on this assignment because they authentically did every single problem in the sections. You made some mistakes, that's fine, especially over the summer when you didn't really have a lot of opportunity to get feedback from me. I appreciate the effort that went into this, and we're just going to learn and grow from here. It's all good. It is clear to me that we all need some collective work in the world of trigonometry. Inverse trigonometry. That's a thing. Solving trig equations. I'm seeing some patterns here. It's called trig. Good news, you're going to get lots and lots and lots of practice with trig and logs and exponentials and all the things. I'm not going to like do a day where I'm like, hey, let me reteach you the unit circle, but as these things come up, we're going to tackle them together. Okay? Friends at North Central, I have no idea what you all are doing there with the summer assignment, so, talk to Mr. Similar about that. All right, anybody else? Survey for me. All right. Thank you, Lewis. Looking nice and tucked today. All right. So, there are 4 reasons that a limit may not exist. Who can give me one? 4 completely different reasons why a limit could not exist. Celeste.
Because the limit would not exist because the limit from the right is not equal to the limit from the left.
The limit from the left and the limit from the right are not equal to each other. Like maybe you're seeing something like this on the graph that we would call a jump discontinuity. Holes in the graph okay?
Nope.
Yes.
Holes are okay because remember with limits, I'm not asking what happens at the point. I'm asking what happens as you get close to the point. That's why holes are going to be okay. So that's one reason. What's another reason? Stephen.
Oscillation.
Oscillation. What do you mean by that?
Meaning like the graph wiggles.
The graph wiggles. It wiggles a lot without ever actually getting closer to one particular number. So that's the thing. So limit from the left, limit from the right, not equal to each other. Oscillation, that's a second thing. There's a third thing. There's a third thing. Ale?
Unbounded behavior. Unbounded
behavior. Your graph heads up to infinity or down towards negative infinity. There's a fourth thing. David.
Domain restriction.
One more time.
Domain restriction.
Nice. Way to like hang back for a little bit and take on the tough one. If you have no graph because there's a domain restriction, the limit may not exist if you're approaching from that particular side where the graph doesn't exist. Everybody okay? You will never, ever, ever polymon. Just right does not exist. Ever polymon. You get this?
You're always going to write does not exist because, and here's the scary part, the because better be the right because. If you're like, but coach, I wrote does not exist, I'm like, good, why? It's the why that I care about the most. All right, so let's come back to what we were doing yesterday. I want to do 3 model problems with you all, and then you guys are going to get some time to do some partner practice, and life is going to be good. Yesterday we started talking about this thing called mental math, or I may refer to this as graphical analysis. It's the thing that you do if you see that you're going to be taking the limit as x approaches infinity, or if it's the limit as x approaches negative infinity. I just want you to have some like visual cues for when we're going to do this like mental math thing. If I'm dealing with the infinities, usually this approach is going to be a good one, because you cannot plug in infinity. I never, oh, it would hurt my heart if only I had one. I never want to see something like 1 divided by infinity equals 0. That's nonsense. So with the infinities, you cannot plug in infinity, so we need to avoid that. Okay, another time that you're going to use this mental math is if you see a number being divided by 0. A number divided by 0, how do we feel about this?
No.
It's not possible. Some people say the universe explodes. Okay? So if it's a number divided by 0, we're going to try this mental math. Also, if you have parameters, right? Parameters, those are like the variables, but they're actually not changing. It's like it prevents you from being able to type into your calculator. And there's a 4th reason that I cannot remember right now. If you're approaching infinity, if you're trying to divide by 0, if you've got parameters, oh, so awkward. What the? Hold on, I'm supposed to know these things. Ha ha! David, when you see that you have domain restrictions. Domain restrictions. Okay, my apologies. I'm supposed to be smarter than that.
It's all right.
All right, thank you. Thank you for lowering the bar a little bit there. All right, so let's do these 3 problems, then you guys are going to get some time to practice. This is definitely the new thing. All right, so first one. What are the thoughts here?
It approaches infinity.
We're approaching infinity, and that should be clue number 1, that we're going to do this like mental math thing. Now, you might say, hey, but sometimes when we're approaching infinity, all I have to do is look at the graph, or there's a parent function that I know. Does anybody know what the graph of the sine of the natural log of pi times e to the negative x looks like?
Oh, wait.
Nobody does. No one on the planet actually knows exactly what that graph looks like. So instead, we're going to take this in pieces. So as x is approaching infinity, start small. Where is there a part that you do know? As x approaches infinity, what do you know, Polygon?
It's approaching 0.
What's the it? You said it, that didn't make it.
The
Where's the first place the x shows up in this function here?
E to the
yeah,
E to the negative x. Do you guys know what that graph looks like?
exponential.
Could you sketch it in the air for me?
This.
E to the negative x, it's so funny you guys are doing like completely different things. The people sitting behind the camera, don't worry, no one's actually going to see the camera unless I spin it around on you. Is e to the negative x increasing from left to right or decreasing from left to right?
decreasing.
It's decreasing. So the graph of e to the negative x decreases from left to right. So what happens as x approaches infinity? What happens to e to the negative x?
Approaching 0.
Approaches 0. Now maybe you want to be like really picky and say like not only is it approaching 0, I'm approaching 0 through like positive values. I'm above the x-axis. Good. That's not the whole problem though. I then have to say, well, if this part is approaching 0, what about pi times e to the negative x? What happens there? As x approaches infinity, e to the negative x approaches 0 from the right. Pi times e to the next has to then approach 0 from the right. So we're done? The answer is 0?
No.
No, why not? Stephen, why not?
Sine. Oh, natural log.
Now you're gonna tell me like, okay, fine. I know that as x approaches infinity, e to the negative x approaches 0. Pi times e to the negative x approaches 0. But now my question is, what happens to the natural log of pi times e to the negative x? Think about that natural log graph. If this part here, called the argument, is approaching 0 from the right, what does that natural log do? And if you're not sure what the graph of natural log looks like, grab that parent survival guide. This is how I'm gonna gently put all the parent functions back into your brains. Natural log of x graph.
Yeah, it's flip.
It looks like that, right?
Flips over that.
So the thing I'm taking the natural log of, this part gets closer to 0 from the right. Get me closer to 0 from the right. What happens to that graph? What happens to those y values? They're approaching negative infinity. Still not done. Still not done. Because I'm not asking for the limit of this natural log of pi e to the negative x. What I really want to know is, what happens to the sign of the natural log of pi e to the negative x? E to the negative x approaches 0. Pi times e to the negative x approaches 0. The natural log is approaching negative infinity. And now I'm asking you to take the sine of something that approaches negative infinity. Lewis, what happens with the sine graph? Right, if the angle is approaching negative infinity, what does the sine graph do? It oscillates, okay? And so I'd say something like this guy oscillates. So your final answer, your final best answer is going to be the limit as x approaches infinity, sine, natural log, pi e to the negative x does not exist. Polynomial you're satisfied with does not exist?
No,
Why not?
because of oscillation.
Does not exist because of oscillation. Yeah, Stephen.
So basically, you just look at a problem and if it says like sine or cos, and as long as it's approaching infinity, you can assume it's not exist.
Yes, but what if in like all this stuff that we did, the angle wasn't approaching infinity? Like maybe it's like limit as x approaches infinity, but because of all these other functions we had to pass through first, maybe for some reason this was getting closer to like pi. And then you'd say, oh, well then the limit of sine of stuff gets closer to sine of pi. Okay, I want you guys to try number 2. There's a mistake on number 2, my apologies. We're going to approach 5 from the left, not from the right. Let's take a minute or two, see what you can do. Is it cold in here, or is it just me? Okay. Never get cold. I have such good padding. Don't laugh at that.
That's how you go.
Where should?
So you must put.
If you think you get the second one, just call me on over and then you can move on to number 3. How do we feel about direct substitution here? Are we just going to plug in?
No.
Plugging in, not going to be a thing. Carmen, why? Why are you not going to plug in?
Because since you're approaching 5 from the left, if you use any number less than 5, it's going to create a negative number.
Oh, you spoiled all the fun there. All right, so I was hoping for maybe something smaller than that. Like, could there be a domain restriction with this function? Right, I see all those square roots. I might be thinking about domain restrictions. You jumped all the way to the end, okay? If I'm approaching 5 from the left, as x approaches 5 from the left, what's going to happen? There's a problem here. In the numerator or the denominator? The denominator is going to be the problem. Right, the problem is that if I think about x minus 5, what happens there? X gets closer to 5 from the left. And in my old man brain, I sometimes have to be like, hey, old man brain, what's a good number to the left of 5? Like 4.9, 4.99999? 4.999 minus 5, I know that's getting close to 0, but from the left it's a negative. So that means that the square root of x minus 5, what do we know about that? If x minus 5 is getting close to 0 from the left, then the square root of x minus 5 doesn't exist. Doesn't exist. In calculus class, we're going to say does not exist because of domain restriction. Okay. So I would just go up here and say does not exist because of domain restriction. Now, here's the thing. With the 11 super Smarties that are in the room, and the 5 not actually in the room but watching at home, a lot of this stuff, the reason why I think this is mental math is I think for a lot of you, you can just kind of like talk your way through this or think your way through this, and you're not going to necessarily have to write all the things down. If the angels whisper to you in such a way where you're like, yes, I've got this, then it's okay. You don't have to write it all out. Everybody okay? So let's see if we can do this last one together like real quick. We've got a not equal to 0, b not equal to 0, and what I want to do is evaluate the limit as x approaches infinity of all the stuff. Good candidate for this mental math idea? Right, I'm approaching infinity. I also see the parameters, the a and the b. Let's see if we can talk our way through this. X is approaching infinity. Where does x show up in this function? It's showing up in the exponent. E to the negative 0.005x. What does that graph look like? E to the negative 0.005x. Increasing from left to right or decreasing from left to right? Decreases from left to right. So if e to the negative 0.05x decreases from left to right, what happens as x approaches infinity? This approaches 0. Let's see if we can finish it off from here. If this part approaches 0, what about b times something that's approaching 0? Also approaching 0. Not b, 0. Right, this part gets closer to 0. B times something close to 0 is 0. Now I'm adding 1. So now I'm close to 1. So 1's the final answer?
No.
Final answer is? A over 1, which we're just going to say is A. It is 100% okay and strongly encouraged. A multiple choice question. If you can do this in your head, go for it. Okay? Ale, if you don't mind, can you work with Palomon for the next 10 to 12 minutes
so
or so?
sorry.
It's not my fault. Blame Aaron. All right. Here's what you're gonna do. You and your partner over the course of, let's call it 10 minutes. One of you is partner A, one of you is partner B. The better looking person is partner A. Decide who partner A is. All right. Here's how life's going to work. If you're partner A in each set of problems, you're going to do the problem for partner A. Partner B, the ugly person, is going to do this problem over here. When you're both done and you're ready for some feedback, I want you to trade papers. You're going to have some conversation.
So Myra might be doing the partner A problem, Celeste is doing the partner B problem, or whatever the relationship is there. I don't know these things. Okay, so Celeste apparently is doing partner A. We know about Celeste now. And Myra is doing partner B. I want you guys to check each other's notation. Does it make sense? Does the whole argument hang together? And do you agree? If you're feeling good, move on, move on, move on, move on. But you're going to move on together in pairs. Okay? Show me what you can do. And somebody needs to take the Friends from North Central. Okay. Okay, Friends from North Central. Stephen is the guy on the right. David is the guy that's on the left. As they're working through their problems and having conversation, they're going to speak loudly enough that you can hear them, Stephen. Don't lean out of the picture. Don't kick my camera either. All right. So the 5 friends from North Central are listening in on your conversation. Stephen, when I pull everybody together, turn on the camera. Okay.
Okay.
I know this is gonna be all good. I need to work on this. You got it? Yeah. I'm not sure this is correct, but you can't approach from the right since it's going towards the infinity, right?
Well, it's basically the whole graph. Like, it's not asking for just the right. It's asking for like say approach to infinity.
So basically, it is possible to approach from the right,
Yeah.
since it's infinity. Alright, so it's 0. It'll be 1 over infinity, which is not a real thing, but it approaches 0.
Yeah.
Wait, did we just do one problem in turn?
Hey,
So
well,
for like these problems,
well,
they're,
basically we
depending on the number of
Coast.
they're
we benefit.
Is that always the case?
Not necessarily. It's going to depend on the
K is
function.
less than 0.
Like if I'm approaching 5 from the right, how does that change things?
So basically,
What's the hit though? That's all right.
Okay, so this one was because
Okay, X. Let's start small. X
Wait,
minus
0.
5 is going to approach
Yeah,
0.
because K
From the
is
right or
a
the
negative
left?
number.
yeah.
So
the right.
the
Okay,
graph is
square
going
root.
to come from the left all the
Absolutely.
way down. And
So you're getting
approach
closer to 0
zero.
from the right. You're taking the square root,
X.
which is
It's
negative close to 0 from the right, and 1 divided by close to 0 from the right.
Because of unbounded behavior.
It's like you keep things out loud.
Because,
Oh wait, I think we're.
but you're not divided by 0. You're getting
Oh, I'm sorry.
Even though you do it so much.
so 1 divided by
Number
close
2
to
is
0.
actually does not exist because of unbounded behavior.
So if this had been a like limit as x approaches
Number
5 from the
1,
right, the best way
0.
to summarize this would be to say does not exist because of unbounded behavior. Coming from the left, you are 100% correct to say does not exist because of the domain inversion, because you have a negative underneath.
Which one has a domain?
Friends over here, how's it looking? You guys give each other feedback.
Alright, do we? 5 from the left. Is this one correct? 0.
I don't know, what did your partner say?
He said it's also correct.
Well, there you go. What do you need me for?
Making sure we're both right.
Because it's not just about the 2 of you, it's about the 2 of you plus the friends at North Central.
Of course.
Yeah,
Yeah.
it's the whole family. Yes.
Thank you.
You're welcome.
Do we move on?
Yes.
Alright.
Those were the instructions.
1, 3.
Hello, friends. How are you? Okay. What's
Are you sure about the x squared part?
Would you like one?
What happened?
No, I skipped it. I got sick.
Okay, 1 over x is 1 over x.
Okay. We know that it's,
It's in here, it's in here.
One over x is going to be.
what happens to x squared?
Isn't it this way?
Yeah.
Oh, it's like this.
That's going to be.
And then you got this.
Close is right.
And what are you doing?
That's not bad. That's I don't think it's gonna be does not exist because of oscillation. Because it's close.
But computer differences.
One.
No, it's not that.
There's no.
No,
No, you're right. It wouldn't exist because
Yeah.
One,
But which one?
trade.
I'm assuming it's gonna be the close aspect. There's a secondary.
Probably.
So it's gonna be
Limit of
unbounded oscillation.
1 over x.
I'm just go with oscillation.
That's a good question.
Do you need because of oscillation?
Yeah.
I'm assuming remember at the end.
Yes, sir.
Oh,
I
yeah.
think so because you see all the both right?
Yes.
Then if we think about
Hello, friends. How are we doing?
approaching
Yeah.
For this one, would it be does not
curvy
exist
thing.
because of boundary behavior or
So-
because of oscillation?
it's oscillating.
I think it's oscillation because the coast is a
So
secondary
it's
thing. It's only
not exist because of
depends on
oscillation.
Yes, sir.
Okay.
So as x is approaching 0 from the left, 1 over x is approaching negative infinity. And if that's where I wanted you to stop, you'd say does not exist because of unbounded behavior, but I want you to go further and talk about
Does not exist because
cosine
of
of
domain
that.
restriction.
And the cosine of that, if the angle's
You plug
approaching
in
negative
this is
infinity,
approaching from the left.
then does not exist because of
You're gonna
oscillation.
have to plug in like 4.9. You know it won't exist, right? Since you're screwed, you get negative number. Nothing there. Okay, sweet.
How are you feeling about the calculus packet? This is a good thing.
I like it.
We like the calculus packet?
Yes.
Friends over here, calculus packet's a good thing?
Like I don't have to actually try to remind me yet. This one's gonna be
All right, friends. Steven, if you could do your thing there. Okay. I don't think anyone has gotten through all of these, and that's fine. But I'm going to put my work up there for 1 through 6, and then we can have a quick conversation about one more. All right. So, number 1, if all goes well, you've got 0. Okay? And if I was going to write it out, here's all the things I would write it out. X is approaching infinity. X squared plus 6 is approaching infinity. But I'm taking 1 and I'm dividing it by something approaching infinity. The whole thing gets close to 0. Write it out using good notation, or just know in your head 0 and it's good. Okay, number 2, e to the kx. Well, k is negative, so we're decreasing left to right. As x approaches negative infinity, the answer is going to be positive infinity. Or better than that, does not exist because of unbounded behavior. Okay. Number 3, because x is approaching 5 from the left, think like left of 5, like 4.99999. That number, minus 5, is a negative number. It's underneath the square root sign. Can't take the square root of a negative number. Does not exist because of domain restriction. Number 4, x is approaching 0 from the left. Polymome, this is the one we were just talking about. If x approaches 0 from the left, what happens to 1 over x?
it's
What about the graph of 1 over x?
it's unbounded behavior.
Right, 1 over x does like this thing and this thing.
Yeah.
As x approaches 0 from the left, 1 over x approaches negative infinity. And if that's where I wanted you to stop, you'd be like, oh, I'm done, does not exist because of unbounded behavior. That's not where you're stopping. You now have to talk to me about cosine. What's the cosine of something that's approaching negative infinity? Lewis?
Does not exist because of oscillation.
Does not exist because of oscillation. Mostly okay?
Yeah.
We are definitely already past anything you would have done in pre-calculus when it comes to limits. It's okay. Enjoy the ride. It's going to be beautiful. All right, number 5, as x approaches 0 from the right, pi times x must be approaching 0 from the right. What happens with the sine? The sine of my angle gets closer to 0 from the right, the sine gets closer to 0. 1 divided by something getting closer to 0 is going to head off towards positive infinity. Better answer, does not exist because of unbounded behavior. All right. Everybody good? Now it's time to break you. All right. Let's see what you guys can do with this one in the bottom, where it says, show me what you can do. You are allowed to solve this problem in whatever way makes sense. I have no boundaries, no restrictions. Any way you want to try this problem, go for it. If you get it wrong, you're cut from the program. David, you okay? What? David, you okay? Okay. Aaron, you're going to be watching this video from home. I miss you. There are no restrictions with how you choose to solve this problem. I see some people trying some mental math skills. I see 1 or 2 people that have a graphing calculator out. There are no restrictions on this problem. Oh, you're laughing at Lewis because he can't find his calculator. Yeah, let's all mock him. Okay, Carmen has cracked. She's using her calculator. Polymone's just balling up paper. He's also cracked, but in a different way.
Huh?
Where's my
calculator? Okay, where is my calculator? Did you not see me?
All right, so I'm seeing a couple of, how many guys started with this like mental math idea? Okay, just about everybody, right? So, all right, as x approaches infinity, what do we know?
0.
0.
No, as x approaches 0.
As x approaches 0, okay, good. As x approaches 0, what happens to 1 over x?
Wait. Unbounded behavior.
Careful, what happens there?
Right,
If I come in from the left, I go down towards negative infinity. If I come in from the right, I head up to positive infinity.
Yeah.
So depending on the side, I'm either approaching positive or negative infinity. You would say, oh, but it doesn't exist, right? Because the limit from the left and the limit from the right are not the same. You might go on and say, oh, no, but wait, it's even worse than that. We have unbounded behavior. And then you might say, well, how about the sine of 1 over x? What happens there?
Does not exist because of oscillation.
This guy's oscillating. Oh my God, we've got oscillation. And then you might even go on a little bit further and say, wait, but what I really want is I want x times the sine of 1 over x. What's 0 times something that's oscillating? Don't answer that. I don't know. It is a great big mathematical mystery. How would you actually answer this question with the tools that are at your disposal? Where are my friends who graphed this on the calculator? You graphed it on the calculator? Can I borrow your calculator? I want to see if I can pull this off here.
Oh, okay, no, you won't let me borrow your card. Give up the calculator. Never mind. Okay, no, I don't want to separate you from your calculator. Flip the page over. Okay. So what I did, because I had this premonition that taking the calculator from Carmen was going to be impossible, I graphed x times sine of 1 over x on my calculator. And I put in some other functions that might be helpful for you. Based on the graph, what's your answer going to be? This guy in here, that's wiggling and wiggling and wiggling, and then you get past it and you wiggle, 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 and you go on up. What's the limit as x approaches 0?
Can't really see.
What do we think?
Not close.
You've got the graph in front of you. What's happening? What's happening to those y values?
Decreasing.
As I get close to 0 from the left, what happens?
Closer to 0.
I'm getting closer. What are those y values doing? They're getting closer to 0. What if I come in from the other side?
Same.
Also coming in closer to 0. So the right answer here, what's the limit as x approaches infinity? Based on the graph, you're going to say that the limit as x approaches 0 of x times the sine of 1 over x is equal to 0. This goes way beyond anything that you would have done in pre-calculus. This goes way beyond anything that we've done so far in AP calculus. Hopefully with the graph in front of you, not so bad, but mostly okay. I want to use this as my introduction to something that is also new in the world of AP calculus. The world of AP calculus changed last spring. There's a new calculus curriculum. There are some new ideas that you're going to be exposed to. Here's another one. It's called the squeeze theorem. What's it called?
Squeeze.
Squeeze. You're going to squeeze a function. Like you would squeeze a lemon and the juice comes out. Like I'm going to squeeze your brain and the juice comes out. The reason that I included these two other functions, the absolute value of x and that was so awkward. Y equals the absolute value of x, that's the black one. Negative absolute value of x, that's going to be this red one. Look at what's happening with these two functions. I've got this x times sine of 1 over x graph that, quite honestly, no one actually knew what it looked like. But what I know from graphing is that the graph of the absolute value of x is always above the graph. And negative absolute value of x is always below. Are we okay with that? These two functions together are squeezing, they are compressing, not compress, let's say squeeze. They are squeezing, they're trapping the other function, the x sine 1 over x. This is the first time I've ever explained this to any human, so just know it's going to get better. Is everybody okay that the green graph is trapped, squeezed by the black and the red? What the squeeze theorem says is this. Do we know the limit as x approaches 0 of the absolute value of x? We know that that limit is 0. And do we know the limit as x approaches 0 here? 0. If the function that traps me from above and the function that trapped me from below are approaching the same answer, then it must be true that the green graph approaches the same answer. Okay? I've never explained this to a group of teenagers before, so, okay? So, let's go for the formal definition here. Ayla, do you mind reading the formal definition here?
Consider a function f of x that is bounded between two functions, h of x for the lower bound and g of x for the upper bound. On an interval containing x equals c, that is, h of x is less than or equal to f of x, which is less than or equal to g of x for all values of x in an interval containing c, except possibly at c itself.
Wow. You didn't breathe at any point in that. That was impressive. Okay, let's go back. Important things here. What are the important things that Ile just read at the speed of light?
H of x bounds the lower part and u of x bounds the upper.
Okay, so we've got a lower bound. Now here's the thing, friends. It doesn't have to be that you call the lower bound h. It could be f, c of x for Celeste, g of x, m of x for Myra. Okay? It's like day 4, friends. Okay, you've got a lower bound and you've got an upper bound. This is the thing. Okay? The job of your lower bound and your upper bound is to squeeze, to trap your function. Just like you all are trapped in this room with me. All right, h of x is less than or equal to f of x is less than or equal to g of x. This is essential. It must be true that your lower bound is always less than the function that you're testing. So we'll say like function being tested. And g of x is your upper bound. Now the one place where you do not need this inequality to be true, the one place, is at x equals c. X equals c is the place that you're actually trying to evaluate the limit. Okay? So this inequality has to be true for values of x around x equals c. So if I draw like a little interval here, is it true that for all the x values in here, h is less than f is less than g? Is that true for every value in that interval? Any x value I pick, h is smaller than f and f is smaller than g. True? It doesn't have to happen everywhere. It just has to happen around x equals c. It doesn't have to be true at x equals c. So like over here, like I would make a little note, like holes are allowed. Pretty much holes are always going to be allowed when it comes to limits. Because, why?
We're approaching it.
You're approaching. No one actually cares what happens when you get there. It's about what happens as you get close. So as long as I get close to c from the right and c from the left, h is less than f is less than g, and this relationship is true. My lower function has a limit, my upper function has a limit, and they better be the same limit. So like lower bound and upper bound are the same. Well, if your lower bound and the upper bound are the same, and f is trapped between h and g, if h is getting closer to some number L and g is getting closer to some number L and f is always trapped in between, what has to be true about f? You have to approach L, right? Because f, this function in the middle, never gets to be taller than g, never gets to be less than f. It's always trapped. And if the two trapping functions are squeezing f as we get closer to c, then that limit has to be the same. Totally new idea. Totally new idea here. So let's actually just do one quick one, and then you guys will be free of me. All right, so using the squeeze theorem. Right now, since we don't know a lot about the different functions, I'm just going to tell you some things. It can be shown that for any angle x, with x not equal to 0, cosine of x is less than or equal to the sine of x is less than or equal to 1. I'm asking you to believe me. I have not lied to you yet that you're aware of. Okay? Is everybody okay just accepting this fact?
Mm-hmm.
Right, what you're going to find with the squeeze theorem, the tough part is picking the right functions. Like, how do you know what's the right one for above and what's the right one for below? Here I'm telling you this. Using this information, I want to find the limit as x approaches 0, sine of x over x. Well, what I'd say is this. I would say that we know for x not equal to 0,
We know that the cosine of x is less than or equal to sine of x over x, and that has to be equal to 1. Well, what's the limit as x approaches 0 of the cosine? Cosine graph, what happens, what's the limit as x approaches 0? And if you need to look at your survival guide, look at the survival guide, it's okay. The cosine of x approaches 1. What's the limit as x approaches 0 of 1? Easier than you think. 1. This cosine graph, you know what the cosine graph looks like. 1 horizontal line. If you were to graph sine of x over x, you're going to see that the sine of x is trapped between these two. The conclusion, because I know that cosine of x is the lower bound and 1 is the upper bound, and sine of x over x is always in between them, what's the conclusion here?
It's gonna be
Right? But I'd want to see this. By the squeeze theorem, it must be true that the limit as x approaches 0 of sine of x over x is equal to 1. Not too bad if you're given the right functions. If you're given the lower bound and the upper bound, the only thing you have to check, do they converge to the same thing? If that's true, then the function in between must actually have the same limit. Everybody okay? We're going to continue talking about the squeeze theorem, so don't freak out. Don't drop the class. Don't go apply to work at Walmart. We're all still going to college.
What if it's just a temporary job?
No, don't work at Walmart.
Don't work at any other thing.
Don't work any, look, trust me, I'm going to work you hard enough in this class. You won't have time to work. You also won't date.